Alright, if a parametric surface S is given by a vector function, r of uv, then there are two useful families of curves that lie on S. One family with u constant and the other with v constant. These families correspond to vertical and horizontal lines on the uv plane. We call these curves grid curves. So what we're going to do is we're going to find parametric representation for whatever surface that it gives us. And sometimes we can write it in terms of UV. Other times it's going to be much more less complicated than just going ahead and solving for X, Y, or Z. And then we can, take our object and translate it to either the XZ plane, the YZ plane, or the XY plane. All right, so for example, to find a parametric representation for the surface. Right, so the plane that passes through the point 0, -1, 5, and contains the vectors 2, 1, 4, and -3, 2, 5. So here what we have is we're given a point with two vectors. Let me change this. So there's my point, there's the two vectors. Whenever I'm given, just, a point, or whenever I'm trying to find, and try to reparameterize, a function where I have a plane, what I can do is I can just take the initial point and then add the vectors to the corresponding components. So u of a plus v of b. So what I'm doing is I'm just taking the point and then I'm just adding, the a vector, and then I'll be adding the b vector, and so I give this little hat symbol too. And there's, I'm going to be able to find the other point. And so that's what we're doing here. We're just, we're given a point and we're given two vectors that also lie on the plane, and we're going to, be able to reparameterize this in terms of u and v. So we start off with x. R sub 0 of x is just 0 from our point, plus u of a, which is going to be our x component, plus -3 is also our x component on b, and there we have x reparameterized as 2u minus 3v. And then we do the same thing with y and z, and we'll be given y is equal to -1 plus u times 1 plus v times 2, and z is equal to 5 plus u times 4 plus v times 5. And then we have our plane reparameterized in terms of x, y, and z. Alright, in terms of u and v for x, y, and z. Example 3. Find a parametric representation for the surface and the part of the ellipsoid x squared plus 2y squared plus 3z squared equals 1 that lies left of the xz plane. Alright, so what we want to do now is we want to, have our viewpoint from the left of the xz plane. And so therefore, it would be easier, instead of turning things into terms of u and v, we can go ahead and take our equation and we can solve this equation for y. The thing is, we can parameterize, x or z, but because we want to do it from the xz plane, that's why we want to go ahead and solve for y. If we want to do it to the yz plane, we could solve for x. Alright, so since we're doing this to the xz plane, we're going to solve for y, and we're going to have it in terms of just x and z. So we'll have y is equal to, some function, we call it g, could call it f, and where our two variables are x and z, and therefore we reparameterized it. So all we have to do is just solve this equation for y. So we're going to go ahead and shift everything over to the right, take the square root, and we have plus or minus the square root of 1/2 1 minus x squared minus 3z squared. Now again, that lies on the left side of the xz plane. So if we're taking things on the left side of the xz plane, then we want the negative value. So therefore, x is just going to be x, z is just going to be z, and y is going to be in terms of x and z. So therefore, it's just reparameterized. Alright, so you can think of this in terms of, when we're working on, trying to find surface area or looking for representations of our surface, we can just solve for x, y, and z. But we need to make sure that we know which plane that we're kind of transposing the shape of our object to, xz plane, yz plane, or xy plane. Let me go ahead and highlight the answer and then we'll call it for this one.